The dancing lights of the aurora can be mesmerizing in the cold night sky. But they're also a reminder that solar storms affect life on Earth in many ways.
NOAA, the National Oceanic and Atmospheric Administration, is responsible for space weather forecasting at the Space Environment Center in Boulder, Colorado. We monitor space weather 24 hours a day. We have that responsibility to warn the public when something's happening in the sun that might affect us right here on Earth. We're watching big sunspots in the sun, measuring their size and their complexity.
The sun's turbulent storms ebb and flow roughly on an 11-year cycle. At the high point of the cycle, or solar maximum, there are many more sunspots and storms in the solar atmosphere. This is also when coronal mass ejections most often occur. Warnings that a large solar event is in progress are issued when an eruption is spotted on the sun. These huge explosions impact radio and GPS systems here on Earth.
Space weather for the next 24 hours is expected to be severe. Geomagnetic storms reaching the G4 level, solar radiation storms reaching the S2 level, and radio blackouts reaching the R3 level are expected.
On the 6th of December in 2006, a volatile sunspot cluster appeared in the sun, resulting in a powerful eruption. This actually produced the largest solar radio burst we've ever observed.
We didn't expect there to be a large solar radio burst during the quietest part of the solar cycle.
It just came out of nowhere. It was 10 times bigger than we had seen before, ever. This incredible surprise.
We were counting the number of GPS satellites that were on track, and normally every 30 seconds you're seeing 10 satellites, 10 satellites. All of a sudden it goes down to like 2, 1. I mean, it's like there was this huge effect.
Pretty much every GPS receiver in the hemisphere was affected. Many of them just failed outright, ceased to navigate.
It only happened on the sunlit side of the planet, but it was instantaneous and it was global.
Unlike a CME, this solar radio burst is traveling at the speed of light, so it reaches Earth in 8 minutes. And this solar eruption resulted in flights being rerouted away from polar routes. This extraordinary radio burst itself affected air traffic controllers across North America.
So now we had to just drop everything and rethink this situation. What is the biggest we could possibly get? We just, of course, don't know.
As a society, we've become increasingly reliant on technology. Few people today leave home without their cell phone. Many of us have GPS receivers in our cars. We rarely, if ever, consider the possibility of not having electricity when we return home. We have power grids that are sensitive to the electric current that's caused by these supercharged particles from the sun. Blackouts can cause multi-million-dollar devastation and even loss of human life. Satellite operators recognize that space weather can have a significant impact on their spacecraft, so they point their satellites in a safer direction to protect them from high-energy particles coming from the sun. In order to better support human exploration of the sun and Mars, we must find ways to protect the passengers and spacecraft from the harmful radiation that streams from the sun, especially the fierce outbursts during these violent eruptions. To understand and to be able to accurately predict when these high-energy particles might be coming towards Earth is critical to our future in space.
I can't imagine any other missions that are more directly relevant to humankind. By studying the sun, we are understanding this object that influences our life in every conceivable way.
But to view that in 3D, I really can't quite envision myself. I get emotional if I think about it.
These are the very first three-dimensional images from the stereo mission in their full glory and detail. This cauldron of magnetic soup, spitting out loops, jets, spikes, churning constantly. The science team uses colored filters that reveal the different parts of the sun at different temperatures. The dark regions are called coronal holes. That's where the solar wind blows out. What you also see are these beautiful rays called polar plumes that seem to extend forever. When you see these coronal loops, they come from the hottest parts of the sun. This is where coronal mass ejections can erupt. Because of stereo, scientists will finally understand the true 3D shape of all these structures. They will be able to better predict how much energy is stored inside these loops. This will help solve some key mysteries of the sun.
What touched me the most is this young kid with glasses on, pointing his finger and saying, "I can as if touch it." That's the first reaction of the 3D sun for the rest of the world. It's just jumping out at you.
I've always been fascinated by the night sky, by the stars, the galaxies. What is there beyond? To probe deeper and deeper and deeper into a given object. So I think it's humankind's destiny to move out and beyond, to understand.